Hello everyone, welcome back to our data structure series. I am Sakshi and here is the episode 11th of Learn DSC with Sakshi. In our previous videos, we successfully completed one of the most important topic that is the linked list in both C and C++. And we saw how we connected nodes, how memory is allocated dynamically and how to perform different operations like the insertion, deletion, traversal and count. Now it's time to move ahead. Today we are starting with the two very important linear data structure that is the stack and queue. So let's start with the stack and queue. We'll divide this video into two parts. In the first part, we'll see what stack is, and in the second part, we'll see about the queue. So let's start with the stack. First, let's take a real life example to understand the stack. Imagine a plate of piles. Let's say you have 5 plates, first, second, third, fourth, and fifth. Right. Now you can add a new plate at the top, and you can also remove the plate from the top. Means you can place the plate at the top and you can remove from the top also. You can't remove the plate from the between position or at the edge. So you can add or remove from the top also. So that's exactly how stack works. Stack follows the LIFO principle. That is the last in and first out. Means uh, while taking plates on one another, the last plate is the first plate which we are going to take out first. So this is how stack works. That means that the last element you insert will be the first one to come out. So that is how the stack works. Now let's see about the basic operations in stack. So in stack, we can push the element, pop the element, then top the elements and check the it is empty or not. So these are the four operations which we can do with the stack. So first, what is meant by push? Push means adding the element at the top of the list, right? And pop means simply remove the element from the top. And then we also have the top to check the topmost element, and we have is empty function, that is to check if the function is empty, means if our stack is empty or not. Now stack is a type of linear data structure where only one element is only one end is active. It means now stack is a type of linear data structure where only one end is active. Means the stack data structure uses the LIFO principle, so you can insert it and take out the element from only one end. Second end is not active at all. So to insert the new element into the stack, we implement or uses the push function, and to remove the element, we use the pop function. So this is all about the stack. Now stack can be implemented using the arrays and the linked list. Arrays is for the static element, means where you can statically done the things, and we use linked list for the stack implementation for the dynamic stack. So in this video, we are using the linked list to implement the stack. Now that we know the basic theory of the stack, let's see how we can actually implement it using a linked list in C. We'll write a code that supports the push, pop, display, and count operation. So let's get started with the VS Code. Now let's make a new file and name it as program 18.c. If you understood the programs of the linked list, then stack is very easy for you to understand because we are using the same function just with a little bit of changes. So let's start with the code from the scratch. So starting with the header file, then second header file, stdlib.h. Now, as we are using the dynamically linked list, so we are following our previous structure for the stack code. So what we saw in our linked list code, so we first write the type def structure, then struct node structure, and then after that we are inserting or we are making definitions of our functions, 8 functions, and then from the main function we call it. So likewise, we are going to implement this stack also. So for that, I am writing type def struct. We are going to use the previous this yeah this structure because it is easy to understand also, and it is small, so it makes our code looks nice. So type def struct node, then integer data, then its member are the struct node start next. Only next pointer is there, and then use node, then start p node, and then start pp node. This type date, sorry. So here is the basic structure which we call the node and which has two parts. First is the data to store the value, and second is the next pointer to point to the next node in the stack. We also use the type def in the same part. So to reduce the code, we use p node, which means the struct node star, and pp node means the struct node starter, which is used to need to change the head pointer itself. Now let's start with the operations. So in this stack, we have two major operation. First is the push and second is the pop. So first we are going to learn the push operation. So void push. This push operation is just like the insert first operation of the linked list. Why it is like the insert first? Because while pushing means we are inserting the element, right? So we use the same logic of the insert first to make our push operation. So for that, use our parameters as pp node head and then integer number. So this is how we are going to implementing the push function. So this function is used to insert new element at the top of the stack, and we are using this double pointer. So we can change or modify the original code. Now let's start with the actual code. Now we are dynamically allocating memory for the new node and then storing the value passed by the user. So for that, create one new node and initialize it to null first. Then new n is equal, sorry, new n is equal to, this is dynamically allocation, same as the linked list code. So, then new n data is equal to number and new n next is equal to null. Then we check the condition, means if the stack is empty or not. So for that, if start head equal to null, then make star head equal to new n. Means if the stack is empty, then this new node will be the first node. Otherwise, we link the new node to the old node. So for this, just write the else condition. Else new n next is equal to star head, and then star head equal to new n. Updating the star head. Star head is equal to new n. Means we link the new node to the old node and make it as the new head. And this is how we update the new head. This is exactly like the insert first operation in the linked list. So this is all about the push operation, and that's all. Now let's start with the second operation, and that is the pop operation. So for that, now for the pop operation means this function remove the topmost element of the stack and return its value. As it going to return the value, its data type should be or will be integer rather than void. If we use void, then it won't complete the function or it won't act properly. So we need to return its value, so that we are going to use the integer data type. So int pop, then the parameter is same as the pp node head. Now as this function removes the topmost element, so which function of linked list is similar to this? So this is just like the delete first operation. So we are implementing the logic of the delete first here, and then checking conditions same like the delete first, just with the a little changes. First we are going to declare one variable integer number and initialize it to -1. This integer number, so this integer variable hold the value that we will remove, means it will hold the value of the element which we are going to removing. So that's why we are using the one variable and initialize it to -1. Then one temporary pointer and initializing it to null, and then checking the condition if the stack is empty or not. So if star head equal to null, then print, then simply we can return or print that stack is empty. Stack is empty \n. Or the pop operation means for the delete first function, we have three conditions. First, if the list for the linked list, we understood like if the list is empty, then return from it. If it contains single node, then free that node, and if it is contain the multiple node. Similarly, we are going to inserting the same logic for the pop. So we are checking first if the stack is empty or not. If the stack is empty, then print the message that stack is empty. If the stack contains a single node, then come in the else if part. So else if and give condition how to check it has only one node or not. Then just back star head next equal to null. Next it should be equal to null. If this is null, it means that it has only one element, right? And if it has only one element, then so in the number we are storing the heads data. So star head data, and then we free that head. So free star head, and then set star head equal to null. And in this way we remove that element. Means if there is only one element, we free it and make it the stack empty again. So this is how we can remove the element from the stack if only one element is present. But what if there are multiple elements and then we want to remove the first element? For that, we use the else part, just like the linked list. In else part, firstly, we are storing the same way heads data in the number variable. Then our temp pointer now hold the address of the star head. Then star head is equal to star head next. Star head next. There is no new logic here. It is just we are extra taking this variable, and otherwise all logic is same as the linked list program. So it's not new logic to do. And then again free the temp. So if there are multiple elements, we remove the first one and then update the head. So in this way, this is the complete pop operations. Means if stack is empty, do this. If it contains single elements, then this. And if it is contains the multiple elements. So in this way, we completed the two main functions of the stack program, that is push and pop. Then now let's see the remaining two function, that is display and count. It is same, again same function. Now void display. I will type it fastly because its logic is like the previous one. So void it, start with the while loop, run the while loop up to head is not equal to null. Head is not equal to null. And till then print percentage heads data, comma heads data, and then head equal to head next, update the head. So this is how we can display the elements of the stack. And we can also one print statement at the end to look better that elements of stack are. Now just quickly add the print statement here, printf and elements of stack are. The output will look good. Sorry, we need to add this statement about the while function. So it will display the elements better. Now let's see the count logic. Then integer count, then we note here as it is a call by value function. Then first we are taking one integer variable, that is I count, and initialize it to 0. It will take the number of counts of the stack elements. Then while head is not equal to null, till then it will increment the count and updating. So updating head for going to the next element. Head is equal to head next, and then simply return the count. Return the count. So here I forget to get semicolon. That's why it's give error in the while part. So now, so this is all about the count function. We completed all the major functions of the stack and queue. Now just move to the main function. So write int main, and then first variable, this first means our head in the function. So this then one again one variable, integer variable for the count function. Then we are going to see the firstly we push 3 4 elements, then display, then pop some elements. So first, and I want to, let's say 51 first, or let's say 101. So now I'm going to copy this statement because I want more 3 elements, let's say 4 elements. So here then 51, 11, maybe 21. So and then again display first. Then I rate is equal to, I rate is used for pop. After displaying, I want to pop the element. So pop and of first, and printf that pop element is %d backslash in comma and array. So in this way, uh, we call the push and pop function here, and then again display. So similarly, I'll write one more function here. So after the pop element statement, I write the display first. Similarly, I'll again pop one element, and after that display the stack and then count its element. I just add this part, and now just save your program. To compile and run the program, just open your command prompt and go to your specific directory. So I am in my folder. Now just type the program name. It is program 18.c, then -o my.exe, then my.exe.exe. Now here is the output. Firstly, we insert 4 elements. That is, firstly we insert 101, then 51, 21, and at the top 11 is there. So 11 should be removed. But here said 1, and here it is not also removing the 21. Just fix this. Yes, we are not returning the number. We just remove it. So it will give in a garbage value. So just add return number. So it will return number, and also pop element is 1. It is in the same line. So after that, write just one printf selection. Now just save the program and again rerun it. Yes, here is the expected output. That first see 11, 21, 51, 101. So 11 at the top. So according to the pop, 21, sorry. So 11 should be removed. So the pop element is 11. Then our linked list is 21, 51, and 101. So here is the, sorry, stack. Our stack is 11, 21, and 101. Now 21 at the is the top element, so 21 should be removed. So after popping the elements, 21 removed. And then the elements of stack are remaining two elements, 51 and 101. Now only it has only two elements. One is 101, and then after 101 it has 51. So now it will give us the count that we have two elements. So in this way we implemented the stack in C. I hope I am able to understand you this stack. If you want to get the count after specific insertion, then you can insert the count element. It is up to you where you want to use and what you want to see in the output. So that's all about the stack. Now let's quickly see what queue is. Now let's talk about the queue, what queue is and how it works. So now imagine you are standing in a line to buy a movie tickets. Then the person who comes first obviously gets a first, right? That's how queue works. It follows the principle of FIFO. FIFO means the first in, first out. Means for who comes first gets a first. The element you insert will be the first to be removed. This is how the basic principle of the queue. Now in queue, the basic operations are the enqueue, requeue. Enqueue means just inserting element, just we are giving it to in stack, we use the push operation for inserting and pop for removing elements. Similarly, in queue, we give name as the enqueue for inserting elements and dequeue for removing elements from the rear. In queue, let's see. Enqueue means insert element at the rear. Means we are going to insert the elements at the end in the queue, and we are removing elements from the front. Means let's say we have one line, the person who comes first uh gets to the, let's say there is exit and entry. The person comes from the entry gate, then stop in the line and then get outside from the exit gate. So for the inserting we use rear end, and for the removing we use the front end. Then we have front to check the first element, and then we have empty function to check if the queue is empty or not. So these are the basic operation. We are explain it in detail while explaining the code. Now queues can be also implemented using the arrays and the linked list, just like this type. Arrays means simple or circular queue, and linked list means dynamic queues. Now to implement statically, we use an array. Means we can use array, and similarly for the queue. But due to the use of the array, there is limitation on its size. We cannot insert and remove elements. We cannot insert new elements. So that is the limitation on the side on the size. So to avoid that, we implement stack and queue dynamically and by using the linked list. So to implement of data structure using linked list is called as the dynamic implementation, and we are using the dynamic implementations last from the linked list. So this is all about the queue. Um, I'll draw one diagram to clear the difference between the stack and queue. I'll first draw the diagram and then explain to you. So these are the diagrams for the stack and queue. In stack, only one end is active, as you can see here, and in queue, both ends are active. So in stack, while pushing the elements, here I push elements means it's like the insert first operation, and as stacks works on the principle of the LIFO, then last in, first out. So firstly, 51 inserted, then 21, and then 11. So 11 is the element to get removed first. Then in queue, we inserting last. So means it works on the principle of FIFO, first in, first out. So first 11 is getting inserted, then after 11 we insert 21, then 51. So 11 is the first to get inserted, so it will be the first to get removed. So first in, first out strategy. So for DQ means delete first and NQ means insert last. So this is how the stack and queue is, and it's the basic difference between the stack and queue. Now let's implement the queue in. Now let's start with the implementation of queue. For this, make new program. That is program 19.c. Now just copy this part as it is going to be same. Right. Now Let's start with our function, that is enqueue, dequeue, display, and count. Only four functions we require. Now, first is the void enqueue, enqueue, and its param is it is just like the insert class. So we are actually writing the logic of the insert class. Nothing change it. We just change the function name. Nothing else. Then integer number. Then we node new and initialize it to null. Then we node temp. And we node then also initialize it to null. Then allocating memory. New n is equal to, so without wasting time, just copy this part because this is same. So we so allocating dynamically memory, then for node at two member, first is the data and second is the next. So allocating data to number and then next is initialize to null. Then after that we are writing or we are checking the condition. If the queue is empty, then what to do? So if the queue is empty, if star head equal to null, then star make star head is equal to null. Insert last logic. Here I can comment also. Insert last. So if the list is empty, then say directly to the new node. And if the list is not empty, means if there are elements in the queue, then how to insert at the last from the last end. So for that, temp is equal to star head, then while temp next is not equal to null, means while temp next is not equal to null, till then keep updating the temp pointer, that is temp next. There should not be gap between these two operators, logical operators, and then temp next is equal to our new n. So we traverse to the last node using the temp pointer, then attach the new node to the end, and same as the insert last in the linked list. So this is how of the enqueue operation of the queue. Now let's quickly see the dequeue operation. Its data type should be integer because we are after removing we are returning the element. So int dequeue. Then again its parameter is same as the it should be pp. Oh, sorry, pp node head, just like the get last. It remove the element from the front, means head of the queue. Then we are declaring one variable and initialize it to null, same as from the stack part. So then temporary variable set to as null, temp used to free memory ladder. Now we'll check the condition if it is empty or if it contains only one node or multiple nodes. Now starting with the condition if the queue is empty or not. So if star head equal to null, then print the message that the queue is empty. So queue is empty. \n. It should be here. Now the error is gone. Now then we'll move to next condition, that is else if star head next equal to null, means if there is only one element, star head equal to null, then number is equal to star head data, storing this in the number, and then we'll free that node, that is the star head, and updating star head as null. Star head is equal to null. In this way we dequeue the element, means we save the data free and then set head to null. And if it contains the multiple elements, then set number as head data. So it should be like this: star head data, and then temp is equal to star head. Then we are making star head is equal to star head next. So star head is equal to star head next is equal to star head next, and at the end temp free temp. So store the data, then move it to the next node, and then free the old node. And at the end, don't forget to add the return number. Otherwise, it will not return you the number. So this is all about the. It should be okay. Okay, sorry. Else next. It should be next. And then save your program. So this is how we completed the NQ and DQ operations of the queue. Now just write the display and count function. Actually, display and count is same as the stack function operations. It just display and count the number of elements. So copy paste these two, just elements of QR. QR head is equal to head data and head next, then print, and similarly for count. Save. Now let's write the main part. Again, main part is same, just we need to call those functions. So copy this and paste it here. Now p node first is equal to null. Then irate is initialized to 0. Just where is push, just write the NQ, and where there is a pop, write the DQ. I'm just doing this. So here I update the code, that where is push, I replace it with NQ, and where there is pop, replace it with DQ. Now just save the program, and now just compile it and run it. Go to your command prompt and write program as program 19, then enter my. So here is the queue elements are 101, 51, 21, and 11. So 101 is inserted first, so 101 should be deleted. So the remove element is 101. After 101, 51 should be removed. So here 51 is removed. Now after removing 51, we are left with the only two elements, and that is 11 and 21. So count is 2. So in this way we implement queue also by using the linked list, means dynamically we implement both queue and stack. Now it's time to see how we implement in C++. Just like we implement or we convert the C code to CPP of the linked list, in the similar way we transfer our code C code to CPP for the stack and queue. So here are the CPP code. I already typed it. So program 20 is for the stack and 21 is for the queue. So let's quickly see it. So first we include the header file for CPP. Then type structure is same, and then we create one class, and inside the class tag we implement all our functions like the push, pop, display, and count. Here, just like the linked list, we are publicly, these elements are public, the head and count. Then from the constructor we initialize it to null and 0. Then push operation, again the logic is same, no change in logic, just for the in C, we use the malloc for the dynamically memory allocation. Here we use the new. Then this part is same. And just one more little change is that while inserting, we increment the count, and while deleting, means while pop, we decrement the count as then returning number. Then again here the logic is same for the pop, and display and count elements are again same. And in this way we create the stack object and call it from here. This is all about the CPP code for the stack, similarly for the queue. If you understand one program means how to convert C to C++, then it will be very easy. So just here are the code of queue. Logic is same, just we write the new, then how we have to increment, where to decrease, right? And that's all about the stack and queue in both C and C++. So in this way, we completed the linked list, stack and queue in both C and C++. All right, that's it for today's deep dive into stack and queues. We covered both data structure in detail, looking at their implementation in both C and C++, as well as with their core concept like LIFO for the stack and FIFO for the queues. We also saw how this data structure can be implemented using the linked list and how C++ brings the power of object-oriented programming to help organize and manage the logic more effectively. I hope this video gave you a solid understanding of this fundamental concept. If you have any questions, feel free to drop in them in the comments below, and don't forget to like the video if you found it helpful, and subscribe to stay tuned for more data structures, breakdowns, and coding tutorials. In the upcoming video, we'll saw one project, that is the CBFS project, and we'll implement it in detail. So that's all for today. Thanks for watching, and I'll see you in the next video. Thank you.